Hello engineers, welcome back. And in this lecture, we are going to solve many questions on principal stresses and Mohr circle. And in the previous lecture, what we have done, we have understood how to draw a Mohr circle. So for those who haven't gone through the previous lecture, I would request them to please go through the previous lecture, and the link for the previous lecture you will get on the top right hand corner. Okay. So before starting the lecture, these are few things about me. So let's proceed now. The first question says, consider the following statements. On the plane having maximum and minimum principal stresses, there will be no tangential stress. On the planes having maximum and minimum principal stresses. So this is a statement based question, and it has been asked in ESE 1995. So it says the planes having maximum and minimum principal stress, there will be no shear stress at all. So what do you think, this statement is correct or not? I have explained this earlier, that the principal planes consists of no tangential stress. So yes, this statement is absolutely correct. Next statement. Shear stresses on mutually perpendicular planes are numerically equal. So it says in perpendicular planes, which are mutually perpendicular planes, the shear stress, the numerical value of shear stress is equal. So yes, it is also true. The value of shear stress is always equal, but the direction is opposite. Okay. So this is the direction of shear stress. So this statement is absolutely correct. Now the maximum shear stress is equals to half of the sum of the maximum and minimum principal stress. So in a Mohr circle, let's see this statement. The maximum shear stress. If I draw a Mohr circle like this, let this be sigma 2, let this be sigma 1, and this is tau axis definitely, and this is sigma axis, and we want to calculate the maximum tau max, that is the maximum shear stress. This point will represent the maximum shear stress. This is tau max. So if you look carefully, students, this tau max is nothing but the radius of the Mohr circle. The radius of the Mohr circle is tau max. So how do we find the radius? Radius is nothing but, in the previous lecture we have done this, the radius is nothing but difference between these two, sigma 1 minus sigma 2 by 2. This is the radius. It says that the maximum shear stress is equals to half of the sum of the maximum and minimum principal stresses. It says, what is radius? Radius is sigma 1 plus sigma 2 by 2, but this is wrong. It is not. What this quantity represents, it is the sigma x plus sigma y by 2. What is it? It is the center of the circle. Center of the circle is denoted by sigma 1 plus sigma 2 by 2, but the radius is denoted by sigma 1 minus sigma 2 by 2. This is the radius. So the third statement is wrong. Okay. So out of these statements, how 1, 2 and 3 are correct, 1 and 2 are correct, 2 and 3 are correct. So option B is the correct one option. Okay, answer is B. So let's move on to the next question, students. Here is the next question. The normal stresses on two mutually perpendicular planes at a point are 120 MPa in tensile direction and 60 in tensile direction. If the shear stresses across these planes is 130 MPa, the principal stress will nearly be. So the question says that there is a body, okay, there is a body like this, and the forces acting on this body are 120 megapascal, which is in tensile direction, and 60 MPa, which is in tensile direction. This is 60, this is 60, and this is 120. So these are the stresses acting on the body. Also the shear stress of 30 MPa is acting on the body. Okay. So let me draw the shear stresses first. This is 30, this is 30. Once you draw the diagram now, it becomes very easy to solve the question. This is 30 and this is 30. The shear stresses acting on the body are like this. Now the question says the principal stresses will be nearly. So if you look carefully, students, these are not the principal stresses. The one which are given, 120 and 60, are not principal stresses, because these are not principal planes, because shear stress is acting on it, and once the shear stress is acting on the body, these are not the principal stresses, rather it is just the normal stresses, sigma x and sigma y. Okay. Now our first task is to draw the Mohr circle. Now let's see how to draw the Mohr circle. For drawing the Mohr circle, what we will do, we'll first draw two lines. We'll draw the axis. Let's mark the points. Let's mark sigma x, which we already know. Sigma x is 120 over here. Sigma y, which is also tensile in nature. See, I have already told you that we'll follow the sign convention. The tensile stresses are taken to be positive. Okay, so 120 MPa is in tensile direction, so it is positive. 60 MPa is in tensile direction, so it is positive. So this is 60 MPa. It is also positive. We'll draw them in the positive sigma direction because they are tensile in nature. Now, what about tau? Let's see this 30. It is trying to rotate the body in the anti-clockwise direction, 30 in the anti-clockwise direction. So what is it? I have told you shear stresses which tend to rotate the body in the anti-clockwise direction uh, is taken to be negative. Okay, so this 30, it will be in negative direction. This will be in negative direction. This we have studied in the previous lectures. So those who haven't gone through the previous lecture, please, I'll request them to first go through the previous lecture, and for the link of the previous lecture you will get in the description box, as well as in the information that if you click on the right hand top corner, you'll get the link for the previous lecture. Okay, so please go through the previous lecture first. Now this 30, which is acting here, is taken to be positive. Why positive? It is trying to rotate the body in the clockwise direction, if you look carefully. So let me draw this 30 as well. So these 2 points we have got. Now our next task is to join them using a straight line. These 2 points will lie on the Mohr circle. This is 30, this is also 30. Now using these 2 points, let's draw a circle. That will be our Mohr circle. Okay, so I have drawn a circle which is a Mohr circle. Now our task is to find sigma 1 and sigma 2. So how to do that? Where is sigma 1 and where is sigma 2? The point where the circle intersects with the sigma axis is sigma 1. That is major principal stress, and this is minor principal stress, sigma 2. How to find them? Once we know the center, we have to find the center first. Once we know the center, and if you add radius to it, if you find radius and the center and add radius to the center, you can easily find sigma 1. Okay, so the next task is to find the center. How to find the center? So center is sigma x plus sigma y by 2. This will be the center. So sigma x and sigma y are given. So let's calculate the center. 120 plus 60 by 2. That is, it will be 180 by 2. That is 90. So once we have got the center, the coordinates of the center we have got. This is 90. Now our task is to find the radius. How much is radius? Radius is, we can find it by using the Pythagoras theorem in this triangle. In this triangle we can use the Pythagoras theorem to find the radius. So how much is this line from here to here? How much is it? It is 120 minus 60 by 2. Okay, so this is 120 minus 60 is 60 by 2. This is 30 and this one is also 30. So radius is very easy now. Radius is under root 30 square plus 30 square. This is 900 plus 900, that is under root 1800, that is 10 under root 18. It's 42.42. So once we have got the radius, sigma 1 will be how much? Sigma 1 will be center crest radius. This is 90 plus 42.42. 90 plus 42.42, that is 132.42. 132.42. And sigma 2 will be how much? This is sigma 2. It will be center minus the radius. Minus the radius. If you do that, you will get the sigma 2 minus 42.42. 90 minus 42.42, that is 47.58. This is 47.58. So this thing which we have done right here, you can also learn the formula sigma 1 of sigma, calculating sigma 1 and sigma 2. It is center plus radius and center minus radius. So what is center? Sigma x plus sigma y by 2 plus minus, that is once you have to do plus, once you have to do minus. For sigma 1 you have to add, for sigma 2 you have to subtract, plus minus under root sigma x minus sigma y by 2 whole square. This will give you sigma x minus sigma y by 2. This will give you this distance plus tau square. Tau square. This is nothing but Pythagoras theorem. This is Pythagoras theorem. Okay. We are applying the Pythagoras theorem to find the radius. So this whole thing will give you the radius. So you can, if you want, you can learn this formula as well. The formula will be sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau square. This will give you the values. So we have already got the values of sigma 1 and sigma 2. It is 132.42 and 47.58. Let's check the answer. 132 which is in tensile direction, and 47.58, that is near about 48 MPa. It is also in tensile direction. So answer is D. This was asked in the Engineering Services 2019 examination. I hope this is clear to you, students. It might look like it is very lengthy, but once you master this, it is a matter of just few minutes, 1 minute or 2 minutes, you can solve this question very easily. Now let's move ahead to another question. Okay, this is also a previous year ESE question. I don't know which year, I just forgot to mention it. I'm sorry for that. Now let's continue. The state of stress in a certain point in a stressed body as shown in the figure. The normal stress in x direction is 80 MPa tensile. So normal stress in the x direction, they say it is 80 MPa in the tensile direction, and y direction it is 40 MPa compressive direction. The radius of the Mohr circle for this state of stress will be, so you just have to find the radius of the Mohr circle. Let's first draw the Mohr circle. There is no shear stress acting on this body. So this itself is the principal stresses. Okay. Now our task is to draw the Mohr circle. So let me first draw the axes. This is 80 MPa, which is in tensile direction, which is so we will take it as positive according to sign convention. Tensile stresses are taken to be positive. So 80 MPa we will be taking in the positive direction, 80. And see, the 40 MPa is in compressive direction. So this 40 MPa we will be taking it in the negative direction. Why? Because the compressive stresses are taken to be negative. This 40 is in negative direction. We just have to find uh, the radius of the Mohr circle. The radius is very easy. It is sigma x minus sigma y by 2. So you just put them, 80 minus of minus 40 by 2. This is nothing but 80 plus 40 by 2, 120 by 2, that is equals to 60 MPa. You have to find the radius. This will be this coordinate minus this coordinate by 2. Okay, actually radius will be, the diameter is given to you. Actually the diameter is, the coordinates of the diameter is given to you. This distance is 40 and this distance is 80. Now you just have to find the radius. How will you do that? 80 plus 40 by 2, right? The diameter is already given to you. So it will be 60 MPa. Easy. And this was also a previous year ESE question. So with this, we come to an end of the chapter, and I would like to end this chapter with a nice thought. The best views come after the hardest climb. So that's all for today, engineers. See you in the next lecture with some new topic. Don't forget to like and follow me for more. Bye bye and have a nice day.